before I do anything else, let me close that. Yeah.
I wasn't here last Tuesday.
Oh, it's too late. I'm just kidding. Okay. All right. Let's get the slideshow set up. From current slide. And before we get going actually on this, let me make these few announcements. You've heard this one, I know, or I hope you did, but in case you didn't, beware. Do any of you have classes on Friday or Saturday? Okay. Oh yeah, you do? Friday? Okay, you know what's happening tomorrow? Say again? Veterans Day holiday is tomorrow. Actually, Veterans Day is Saturday, but they're giving us Friday off. So, but I was supposed to announce that before Tef got here, but no, you made it in. Gotta find you now. There you are. All right. So, if you have a class tomorrow, don't come. If you're trying to take care of business tomorrow, don't bother. Okay. Because the college is closed, okay? This, Alabama, state of Alabama, I think recognizes Veterans Day more than any other state I've ever been associated with. It's always a state holiday. Since it's on Saturday, they're giving it a state holiday on Friday. So, don't try to contact anyone. They won't be in, okay? So tomorrow is a holiday, okay? Next, I can't remember if I remembered to ask this class this. I wish more of you were here. But if any of you are going to be here next year, next fall, and would be interested in participating with the math team, especially those of you who might be going up to higher level math classes, but that's not required, but it would be. It's fun. Believe it or not, it really is fun. And there's another bonus. You help yourself out in your future math courses because you'll be exposed to all sorts of tricks, and ways to do problems quickly and efficiently. It's with a great group of people. Miss Nyla Geraci on the Birmingham campus is the coach, and she's asking for. And the thing is, 2 years ago or last year, was our first year with the math team. We didn't, really get started on it until fall, term. We just had 1 month to prepare and then went to our first competition. Actually came in fourth, okay, of those teams that were there. Not bad at all. And then this year, we didn't do anything else except wait till the third right before and tried to cram it in the practice, and we didn't do quite as well. So Mr. Racy is saying we need to start practicing now. So we're going to be practicing, not a rigid, terrible schedule. Whenever you can, we'll work out times and stuff like that, and just get together and have a lot of fun going over math and doing stuff. So if you are at all interested, let me know or let Mr. Racy know on the Birmingham campus. I've always helped coach it if anyone's interested. We'll find times during my many office hours, and we'll have sessions if you want to. It's always fun. It really is. All right. One other thing, school related. I don't know if you remember back the last week in September, first week in August, I started telling you that typically at midterm, it's on the calendar that we're supposed to do a midterm progress report the first week after midterm. Okay? And I was encouraging at the time to get work turned in so I could have something down for you. Well, they never opened it. They never asked for it, so I didn't bother. Okay? Well, this week they asked for it. Okay? Midterm progress reports, a month after midterm is over, they wanted them and they were due in either yesterday or today, so I submitted them. And so basically what I had to do, if I did not have a test score for you, and it looked like you might have been struggling some on the quizzes as well, then I had to put in that you had or if you had a really low test score, put in that you, and they only asked for D's and F's. They didn't care about the other scores. They care, but that's the ones they're focusing on. So you might be getting some sort of contact from someone to see if you need help tutoring or need help with any other issues, and trying to do everything we can to bring those scores up. So if you do get a notice, that's what it's about. So please be ready for that. Which also means get your quizzes in, get your papers in. The papers are a good way, I was telling you back at midterm, to help your average. I've only got 5 in from my second biggest class. 5, okay? We've got just barely a month to go, okay? So please get your papers in. There is 1, 2, okay, who's withdrawn? Okay. 2 people who have not withdrawn that have not even turned in the first quiz. Yes? You can do it either way, but I've received them online before that were in great shape, printed nicely. But I also have received them when I printed them out, the formats were just squirrely. Now, I don't know if the people submitted them squirrely or if the process they use messed them up, but I have to grade what I received. So if you want to make sure, you can print it if you're pretty confident it's going to come across, and most of them do. Vast majority come across just fine. In fact, the ones that were squirrely probably came across right like people submitted them, but they just didn't pay attention to how they were formatted then. So I will accept them either way. But if you will, let me know so I'll watch for it, because I get a lot of spam email. Oh, you got it already. Good. You want me to take it? All right. Good deal. Thank you so much. Okay. So sometimes I miss, if I don't recognize the sender, and since I don't know all your first, well, I do know most of your first initials, but I may not pick up that you're a student here, because a lot of people have used those kind of email addresses. I might not see it. Okay. So that's the second thing. And then the other thing, I said this, I think, last time. I'll try not to dwell on it too much, but I am a really big proponent, and always have been, of voting. Okay? And I hope you know there is a senatorial election coming up the 12th of December. Strange time for an election, but there was strange circumstances. So there is an election coming up. These off-time elections are usually very low participation. So therefore, a very small group of very dedicated people could determine who's our next senator, And that, my wife did the numbers on the primaries, and the candidate that came out with the most votes in the primaries got 8% of the registered voters voted for him in the primaries. 8% determining who's going to be our next senator, that's not a democracy. And that could easily happen during the runoff, this election. So please, folks, don't let it happen. You get out there and vote, because your vote's going to count more strongly in this election, because there will be low turnout. Your voice is louder than it'll ever be in most other elections. Please vote December 12th. Okay, I'm not going to tell you how to vote or for whom to vote. I just want you to get in the practice of voting. All right, enough of that. Well, not enough, but anyway, let's get on to math. Any questions before we get started on today? Let me get my pen set up. All right. Any questions? Okay. If you haven't noticed it, okay, Chapter 2, and especially this last part of Chapter 2, 2.5, is dealing with solving equations, okay? Solving polynomial equations. Finding the zeros of polynomials, okay? We've got our end behavior. That tells us a little something. That's mostly for graphing, but it does tell us something about the zeros. For instance, if you have an odd degree of a polynomial, you know the end behavior is either like this or like that. And polynomials are smooth and continuous, so there's no way in the world there won't be at least one real zero for every odd degree polynomial. Every time, okay? For evens, there could be or it may not be. The odds is going to be at least 1. Okay? Then we did, not necessarily in this order, rational zeros test. That gives us some ideas of what some of the rational zeros may be. And that gets us down at least, in using rational zeros test, we usually use synthetic division. Synthetic division will take us down to, most of the time, to a quadratic. Okay, and if you get to a quadratic, then you can tell. That may have irrational zeros, but you can find those easily. It may have complex zeros. You can find those just as well. Okay? But you know, the rational zeros test gives us tons of possibilities for those zeros, rational zeros. So we have these other tests to help us zoom in, locate, and determine what those zeros may be. Okay? You know that an nth degree polynomial function can have how many real zeros? Up to? Nth degree polynomial can have up to? N zeros. Okay? Now maybe not all of them are real zeros, but it will. In fact, it'll have n complex zeros. Fundamental theorem of calculus tells us that. So, not calculus, algebra. There will be n zeros, but they may be complex. It'll have at most n real zeros. Of course, many nth degree polynomials do not have that many because they have some complex zeros. Okay? This one, for instance, has no real zeros because x squared, when you set this equal to 0, subtract 1 from both sides, x squared cannot equal -1 in the real number system. So it has 2 complex zeros. Okay? Didn't we do this slide last time? It seems so familiar.
Yeah,
We did?
We did.
I must have put my mark in the wrong place. Okay? Yeah. Well, maybe we were working on it before. Okay? This one, you know, has at least 1 real zero. How do you know that?
You can't have a negative on.
Yes, because it's an odd degree polynomial. It's got to cross 1, at least 1. And I think we did this one. What you were saying was absolutely true. You can have a negative cube root. In fact, what is if you set that equals 0, subtract 1 from both sides, what is x squared equal negative, x cubed equal -1, what's 1 root? -1. Because -1 cubed is -1. Sure. That, by the way, is your only real zero. The other 2 will be complex. Okay? And you can find those by doing synthetic division with a -1, getting a 0, find out what the remaining quadratic is, though you know what it is, because you knew how to factor that, right? But that one will have no real zeros, so you can then determine its complex zeros. All right. But there is another method. And this is a theorem called Descartes' rule of signs. Has anyone ever heard of Descartes? Yeah.
He was a contributor to science in the Renaissance period, I think.
Absolutely. Yes, you hit it right on the... Not just science, philosophy, too. Have you ever heard the saying, I think, therefore I am? René Descartes. Okay? Quite a philosopher. In fact, many of his philosophical works influenced both the U.S. Revolution and the French Revolution, or at least the governments that were being formed. The French Revolution got way out of hand, but the founding of our country, some of his philosophical works were groundwork for some of the things we believe. And yes, great mathematician too. In fact, what do we call this? A graph board. It has another name. A system. Anyone ever heard of it? Cartesian coordinate system. You know where that came from? René Descartes. Okay? He developed this. He was the first to basically tie geometry and algebra. Prior to that, they were completely separate fields, not even considered in the same ballpark. He tied them together. And he did it basically with his Cartesian coordinate system, how to graph equations and functions together. Okay? So, great mathematician. You're absolutely right. His rule of signs sheds some more light on the number of real zeros. It doesn't tell you what they are. It lets you know how many you can have. So let's let alpha of x, remember this is a standard polynomial. A sub n, that's some real, okay, remember we're dealing with real coefficients. Some real coefficient of the leading term. Jalen, right? Okay. Just trying to find you. Okay. Good deal. Has anyone else come in since the call roll? Okay? A sub n is a real coefficient of that leading term. It cannot be 0, okay? Because of what we're going to say later, okay? But then these others can be any real numbers in the world. A sub n minus 1 is the next coefficient for the n minus first degree variable. And on down until you get a sub 2, x squared, a sub 1, x to the first, a sub 0, x to the 0, x to the 0 being anything to the 0 power? 1. Okay, so that's why we don't put an x there, because it's always 1. X to the 0 is 1. Be a polynomial with real coefficients as long as that first one, hey, okay, no. For Descartes' rule of sign, also a sub 0 can't be 0. Okay. Okay. If a sub 0 were 0, and you didn't have this, what could you do? Factor out an x from every term, because every term has an x in it. Then you have a polynomial of a 1 lower degree, and then you can go and use it. Okay. So, with that in mind, a sub n can't be 0, and a sub 0 can't be 0. If a sub 0 is, factor it, and then keep going. The number of positive real zeros of L, okay, is either equal to the number of variations in signs. Oh, we got to figure out what that means, of f of x, or less than that number by an even integer. Okay, that's a lot of blah, 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 isn't it? We'll get there. The number of negative real zeros of L is either equal to the number of variations in sign of f of minus x, or less than that number by an even integer. Okay? Much easier to do than it is to write. Okay? Here's what a variation in sign is. It means that two consecutive coefficients have opposite signs. Okay? That's what it means by variation in sign. Really easy to pick out. Okay? When using Descartes' rule of sign, a 0 of multiplicity k should be counted as k0. Remember, every time you have, if it's x, if you have a factor, x minus 1 times x minus 1 times x minus 1, that's 3 zeros, x equal 1. Okay, that's it. Multiplicity of 3. So each of those will count as a 0. So, this one right here. How many variations of sign do you have? Positive, negative, there's 1. Negative, positive, 2. 2 variations in sign. What does that mean? That for positive real zeros, you either have 2 or 2 less than 2, 0. This is either going to have 2 real zeros or no real zeros. That's what it means. Okay? And so it can have 2 positives or no positive real zeros. Can't have just 1. So if you go through your process and you find the 0, keep looking, because there's going to be another positive real 0. Okay? If you don't find any, we'll use other tests to tell you when to stop. Okay? Now, this is not easily factorable, but they show you it is factorable. There's your 3 factors, meaning x equal 1, x equal 1, and x equal negative 2. Those are your 3 zeros. Count the negative 1, the 1 twice. You can see that the 2 positive real zeros, positive real zeros, x equal 1, x equal 1. 2 positive real zeros. Your third real 0 is negative. Okay. You can see that the 2 positive real zeros, x equal 1 and x equal 1. Multiplicity of 2. Okay? So, that gives you a hint to do. If you did your rational zeros test, came up with so many plus or minus, stuff like this, and you found you had a problem like this, you might, this one won't have but two possibilities, so plus or minus 1 and plus or minus 2, but that's 4 possibilities, plus or minus, okay? When you find the x equal 1, and then try it again, find it the second time, stop there, it can't have more than 2. So don't even bother with the 2's. Now, next thing you're going to do is do alpha minus x. And then look how many variations in signs. That'll tell you how many negative real zeros. We know if you found 2 positives, there's got to be a negative. But guess what? You don't even have to do that. Because once you found that first one, 1, then you're going to have a quadratic and you could have captured that. So you already would know that. But that tells you. Okay? Let's do this example. Yeah, there. The example numbers are off. It's example 10 in your book, example 9 on the slide set. But it's the same problem. So determine the possible number of positive and negative real zeros. Positive, real easy. What is it? Okay. 1, 2, 3. Or 1. 3 or 1. Subtract 2. Okay? So this has either 3 or 1 positive real zero. Okay? So, it's got to have 1. You knew that, because it's a cubic polynomial. It's got to have 1, and that 1's going to have to be positive. At least 1. May have more. May have 3. Okay? But it's either going to have 3 or 1. How about checking for negative real zeros? What do we do then? Something we've done before in another situation, in another life, but what was that? F of negative x. Okay? What would that be? Negative 3x cubed. When you put a minus x and square it, it stays positive. So that stays negative 5x squared. Minus 6x minus 4. Hint. Any odd degree is going to change its sign. Any even degree is going to keep its sign. Okay? Real easy to write these down, right? How many negative real zeros you got? How many variations in sign do you have? None. So you have 0 negative things. So when you set up your rational zeros test, all the possible factors of minus 4 over all the possible factors of 3, that would be plus or minus 1, plus or minus 2, plus or minus 4 over plus or minus 1, plus or minus 3. Guess what? Hang up all those minuses. You're not going to have any. So you don't even have to investigate any of those. So you cut your job in half. Okay? And then start working on the positives. Because they're all you're either going to have 3 positive real zeros or 1 positive real zero. The other 2, if you only have 1 positive real zero, the other 2 are going to be complex. You know, so this has 0 negative real zeros. Okay, I probably should put 0 there. Okay? Make sense? All right. Now, they didn't have you find those, but let me erase this, and then we'll see how they did it. Okay? The original polynomial has 1, 2, 3 variations in sign. Therefore, the way it's written, therefore it has either 3, okay, why didn't they go on and do it for this one? So that means either 3 or 1 positive real zero. Then they do alpha negative x, and they did all the steps. If doing all the steps helps you, do all the steps, okay? whatever it is that makes it easy for you to see and understand, go for it. Okay? If you do that, you notice you have no variations in sign, so that means you have no negative real zeros for that polynomial. Okay? So from the Cauchy rule of sign, the polynomial that has either 3 positive real zeros, 1 positive real zero, and definitely has no negative real zeros. Okay? Now they went on and graphed it for you. You didn't have to. Here's what it is, and notice it only has the 1. Okay? And this would have been an easy one if we had gone the next step to figure out what that 1 is, because the first thing you usually choose is 1, right? That's so easy. You just add your coefficients. 3 minus 5 is negative 2, plus 6 is positive 4, minus 4 is 0. Yeah, you know that's the 0. Because when you put like 1 in here and 1 in there, 1 in there, all you have is your coefficients. I actually would have done this way. 3 and 6 is 9, 5 and 4 is minus 9, so I know that's a 0. And then when you do your synthetic division with 1, you know you're going to get 0 as remainder, because it's a 0, and what you have left is a quadratic. Try to factor that, you'll see it only has complex factors, no real zeros. Okay? All right. And fungus here. All right. Anyone else come in since I called roll? Good deal. Now, that was example 9. No, I'm sorry, that was example 10 in your book, 9 on the slide. They don't do any more of those for you. We'll get and do some more. Let's do another test. Okay? Another test of zeros for a polynomial function is related to the sign pattern. And I cheated last time and gave you what that pattern was. One of them anyway. In the last row of the synthetic division array. This test can give you an upper bound or a lower bound of real zeros for F. That's all I can tell you. Can't tell you, it just tells you. A real number C is an upper bound for the real zeros of F when no zeros greater than C exist. Similarly, C is a lower bound when no real zeros of F are less than C. So basically, it gives you, if you reach that upper bound, don't look any further. If you reach the lower bound, don't look any further negative. Okay? And that just saves you some time and effort. And I'm all in favor of that. Hold on, wait. Okay? So here's what the upper and lower bound rules are. You got a polynomial F, real coefficients, okay? Positive leading coefficient. That's pretty important here. Okay, suppose F is divided by a factor F minus C using synthetic division. Now this may not even need to be a factor, you're just dividing. In other words, you put C on the outside, whatever it is, plus or minus, and go to count. Now if that C is positive, greater than 0, and each number in the last row, when you do your synthetic division, is either positive or 0, then C is an upper bound for that real number. Okay? Now, if that last one is 0, that means it is a 0, but if all these others are positive or 0, don't look any further north of C. You won't find it. Okay? Anything greater than C. Even if that last remainder is positive, okay? That last row is all positive or 0, then don't look any further. Even if C wasn't a 0, that's your upper bound. Don't look beyond that value of C. Now, if C is less than 0, okay, it's a negative number you put out here, okay? And the numbers in the last row alternately positive and negative. Now, 0 entries count either as positive or negative, okay? Then C is a lower bound. So if you get this last row down here, now remember we said that positive leading coefficient, so that first one's always going to be a positive number. Well, wait. Yeah, well, it will the first time anyway. After that, yeah, I think it always will be, okay? Then, if plus, minus, plus, minus, plus, or any combination of those, okay, the alternating signs, then don't go anything less than this C, because it's not going to happen. Every one past there will always be plus, minus, plus, minus, plus. If any of these are two pluses in a row, two minuses in a row, keep going on your negatives, okay, until you find them, okay? So, let's do example 11. They don't give it on the slide set. So let's go back and find some white space that we can use. I think that was it right there. Example 11. Find all the real zeros of this. Yuck. Okay. Find all the real zeros of this function. F of x is equal to 6x cubed minus 4x squared plus 3x minus 2. Okay? Find all the real zeros of there. Now, if you wanted to go from the very beginning, we first think about our end behavior. What's the end behavior of this problem? When x is going negative, yes, your function is going negative. And when x is going positive, your function is going positive. That's for very large, not any positive, but very large negative, very large positive. So guess what? We know already there is 1 0, at least 1 0, because you can't get from there to here without crossing the x-axis, not with a contingent function. Okay, that's all that tells you for this. If you're graphing, it tells you maybe a little more, but that's about it. So what's the next test we might use? Method, device. D. Okay, you're going to go to Descartes' rule of signs? Is that what you're saying? Yeah. Okay. What does Descartes' rule of signs tell you?
Change dx to negative.
Say again?
Dx to negative.
Okay, but let's do it first with positive.
So
Three changes of sign, that means you either have 3 or 1 positive real zero. Guess what? We said there's got to be at least 1 real zero. It's got to be positive. That tells you it's got to be. Okay? Got to be. Okay? Now we do the negative, and what does that tell you? Alpha minus x, what would that be? Negative 6x cubed minus 4x squared minus 3x minus 2. What does that tell you? 0 negative real zeros. I didn't write in my zeros there. I should have. That's zeros there. Okay. So, we know we are going to have at least 1 positive real zero. You could have up to 3. Okay? Now, I'm going to erase that next one just because I need room. Okay? So we've already determined we have 0 real zeros, negative real zeros. Okay? So we're going to leave, just keep that in mind. Okay? I need the room. What do we do next? I think the handiest tool for finding zeros. Say again? Yes, the rational zeros test. And what does that tell you? Oh, you said P over Q. I couldn't understand. That's right. P over Q, where P is all the possible factors, plus or minus 2, and all the possible factors of plus or minus 6. And what are those possible factors of plus or minus 2? And plus or minus 2. And in the denominator?
Plus minus 1, plus minus 2, plus minus 3, plus minus 3.
Okay, he talks fast, doesn't he? All right. So, let's list all your possible rational zeros. I like the integers first, so I'll just put plus or minus 1 and plus or minus 2. You get those when you put it over plus or minus 1. Now let's do it over the 2. What would those be? Okay. What you did to begin with is do plus or minus 1 over 1, plus or minus 2 over 1. That's what those are.
Yeah, 2 over 3.
Say again?
Plus minus 2 over 3.
2 over 3. Yeah, so how about 1 over 2? Let's just do it in order, okay? Yeah, this way, and it sort of keeps this level there too. Plus or minus 1/2, plus or minus 1/3, plus or minus 1/6. Now let's do 2. We've already done 2 over 1. We're not going to do that again. How about 2 over 2? 1. We've already done that one. How about 2 over 3? Yeah, that's 1. Plus or minus 2 over 3. And we already got 1/3. So yeah, I think we got it done, right? Those are all our possible rational zeros. But guess what, folks? We have no real zeros. Wipe out those minuses. You don't need them because the Clark's rule of sign said you have no real zeros. Okay, so if you have no real zeros, certainly no rational zeros. Okay, so let's only consider our pluses. So we could have wiped out all the signs there. That would have been easier. In fact, I'll do that. 1, 2, 1/2, 1/3, 1/6, and 2/3. Those are our only possibilities. What's the easiest one to do? 1. Anyone tell me what 1 would be? 6 minus 4 plus 3 minus 2. Add the 0? No. Nope. So 1 is not 1. That's out of there. What you want to try next? 2. Okay? Oh, what am I doing here? Okay? Now, here's one advantage to doing 1 first. You wrote down your coefficients. Okay? You plugged in a 1, that becomes 1, that becomes 1, that becomes 1. You just a coefficient. Guess what? That's your dividend on your synthetic division, isn't it? As long as you're not missing any terms. You have 1, 2, 3, 4 numbers. It's a third-degree polynomial. So therefore, yeah, we got them right. So what you want to try, if 1 doesn't work, what might you try next? 2. I like 2 because it's an integer. They're easier. What do you do first? Bring down your 6. Okay? And? For a second. Okay, and what did you get? A little louder. 12. Okay, and you get 8. You get 16. 19. 38. Add, you get 36. Time out, team. What do you notice about these? All positive. That means 2 is an upper bound. Well, guess what? We don't have any beyond 2 anyway, so sort of done there. But yeah, you don't have any real zeros past 2. Yeah. 2's not 1, and you can't have any past that. Now, that means real zeros. You could have had irrational zeros that could have been later. This says, no, you don't even have those. Okay? So 2 didn't work for us. So what might we try next? Yeah, looks like we're going to have to mess with the 1/2. Okay? Tried to avoid that at all costs, but can't do it. So let's do a 1/2. And what do you get here? 3. Negative 1. Negative 1/2. Second. How much? 2.5, which is 5/2, right? And then this will be 5/4. Ain't gonna happen. But you see you have alternating signs there, so keep looking. 1/2 isn't going to do it, but that doesn't mean 1/2 is not an upper bound. Now, I'm guessing that means we probably need to go all the way to 2/3, don't we? Because if 1/2 is not an upper bound, 1/3 is less than 1/2, 1/6 is less than 1/2, 2/3 is the only one greater than 1/2. So it looks like we need to go there. Let's see. I've never done it this way before, but let's see what happens. I hope I'm not doing something dumb and making a mistake here, but seems like that's it. Put 2/3 in here. 2/3 of 6 is 4, 0, 0, 3. 2/3 of 3 is 2, 0. Yep, 2/3 is it, folks. That's the one positive 0. Okay. Now, what else do you notice here? All positive don't go any higher than 2/3. Okay. Well, there aren't any higher than 2/3. We got 2. We already wiped that one out. We already wiped out 1. So yeah, 2/3 is the last positive. So that means we only have, there's our one positive real 0. You don't have the other 2. Okay? What does this tell you? Oh yeah, what does that get to be? 6x squared plus 3. Set that equal to 0, and what do you notice? No real zeros there, are there? Because x squared is going to be positive. 6 times x squared is going to be even more positive. Add 3 to it, it's even more positive. So yeah, you're never going to get a 0 out of that. In the real number system, the other 2 are complex. Okay? The other 2 zeros are complex zeros. Okay? Now you could factor out a 3 from that. Yeah, that's fine. But you're still left with 2x squared plus 1 is equal to 0. Still no real zeros. All right. Now what did they ask of us here? Find all the real zeros. We found it. X equal 2/3. X equal 2/3. That's our one and only one real 0. Descartes' rule of time told us that. Told us not even mess with the negatives, so we didn't. So we know the other 2 zeros are complex. Okay. Now in the upper bounds test tells you nothing beyond 2/3 is going to work. Not that there was anything beyond there. We already tried 2 and it didn't work either. All those turned out being positive. Okay. So we did what they asked us. Okay. Now, they don't show this one on the slide set, so if you look in your book, you'll see the graph of it. They didn't ask you to graph it, but it looks a lot like the previous one, except the other one was crossing at x equal 1. This is crossing at x equal 2/3. Okay. Now, there's one other, I didn't say this to begin with, one other real easy value that you can plot on your graph. What would that be? You know that 2/3 0 is going to be, the y-intercept is? -2, because x is 0, x is 0, x is 0, or you got this -2. So that's another one. If you look at the graph, yep, it crosses right there at -2. Okay? On the previous one, the y-intercept, back example 10, was -4, but it didn't show up on the graph because they only went as far as -3. So, all right, good deal. Any questions on that? All right. Please do some of these for homework exercises because pretty sure you're going to see some of these on your test, okay? So we only have done 2 little examples with them. Do more. But maybe the application is going to give us an example. So let's try it. All right, application. And it's 11 on the slide, but it's 12 here. You design a candle making kits, okay? Each kit contains 25 cubic inches of candle wax. Okay? That's the volume, by the way. And a mold for making a pyramid-shaped candle. You want the height of the candle to be 2 inches less than the length of each side. So the height is here, each side is going to be 2 inches more than that. Okay? Kind of a short, squatty candle. Okay, big at the base. And it has a square base. So that means you have 4 sides of the base and they each come up to a point. That's what a pyramid is. What should be the dimensions of your candle mold be? You get to make the candle. It's not the mold there. You are trying to design that mold, so you use 25 cubic inches of candle wax. Just what you were always wondering, right? Okay. Now, where do we go from there? Okay? Okay. I would actually probably write it the way it's written here. H is equal to, yes, L minus 2. When it's less than, you flip the order of them because the height is 2 inches less than the length. So the length, whatever it is, subtract 2 from it, you got the height. Okay. Now, that's a good thing to start with. And we're looking for L and H. There are 2 variables. Okay? Here is an equation that gets you down to 1 variable, really, because you can express all your H in terms of L. Well, what do we need? Yeah, and that's the volume of candle wax. So you need a volume formula, don't you? Okay, but you need that volume formula, right? Anyone happen to know what the volume formula is for a pyramid? If you don't, go in your book. I wanted to say front inside cover. I believe that's it. No, it isn't, is it? Used to be. So let's try the back inside cover. Okay? Should be somewhere here. Ha! Here it is, back inside cover. Opposite the hard page, this one over here. Find your your pyramid. Oh my word, they don't have the pyramid in here. A pyramid's a lot like a cone. So if you had a cylinder, you go into a cone, you see a cone is 1/3 the volume of the cylinder. Well, if you had a prism, which they don't show either, length times width times height, then a pyramid is 1/3 that. Sorry about that, folks. I thought it was in here. It used to be in the old edition, but they took it out of the new edition. Very nice of you to do, okay? All right. So here's what the formula is. It would be the volume equal 1/3 the area of the base, that would be length squared times height. Length times width times height is I just said it, I can't think of the word now. A rectangular solid, okay. It has a name for it, but I can't think of it right now. Okay, rectangular solid. Length times width, that's L by L, because that. Here is where I kept expecting someone to say, draw a picture. I was sort of happy they didn't, but now I think it really is a good thing. Draw the base, try to get as square looking as possible, and then you're coming up to a height here. I never can draw them that it doesn't look like one of the lines on top of each other. That's kind of it, with the height being H, and this is L, and L, and L, and L, okay? So that's sort of it. So it's 1/3 the L squared, that's the base, the area of the base, times the height, H. Okay, but we know that H is equal to L minus 2, so the volume is equal to 1/3 of L squared times L minus 2. Okay? Let's work that out. What is that? 1/3 L cubed minus 2/3
right? That's equal to the volume. Okay, but what is the volume? 25 cubic inches. Okay, so we'll put, instead of V, we'll put 25 cubic inches. 25. Now, what's sort of messy about that problem? Even worse. The fractions, okay? Especially the denominators. So how can we rid those denominators? Since this is an equation, you can do this. Multiply everything on both sides by 3. And that gives us, I'm going to change the order to L cubed minus 2L is equal to 75, so I'm going to subtract the 75 and make it minus 75 equals 0. Okay? There's a cubic equation. Okay? Now, where do you proceed from there?
Are you gonna say factor? You start factoring that.
Yeah. Can you factor that? That's the question. No. It's cubic. I don't know how to factor a cubic, except very few ones, okay? But that's a 3-term cubic. Can't do it. Okay, I can't do it anyway. So, what might you try? Now, here's a few things. I notice this is a cubic equation. It's got to cross the x-axis, right? Because this is positive, it's going like this, so there has to be. And I use whose board is that? Descartes, yeah, Descartes' rule of sign, okay? Descartes' rule of sign says that there will be one variation in sign. There's going to be one real positive solution. Guess what, folks? That's all I'm looking for. I want just one value for L, okay? And it needs to be positive. How many candles have you ever lit that had negative links? None, okay? They don't exist, okay? So, we do have one real solution. We got to find it, folks. Okay? And what technique might we use to start finding that 0? P over Q. Very good. Okay? What's your P here? It's P75. And your Q is 1. So, what are the possible factors for 75 over 1?
Plus or minus 1.
Yeah. But you know what? I'm only looking for positive roots, so I'm only going to worry with positives, okay? Okay? So, there probably is a negative root or two, but, you know, I don't care, because I'm only looking for positive lengths, okay? So, 1, 3, 5, 25, 75. All right. Now, I can almost guess the answer right now. What? Look at that. Yeah, it could be 3 and 1, or it could be 3 and 5, because if L were 3, H would be 1. If L were 5, H would be 3. So those are two possible things. That doesn't guarantee those are going to be it, but that would be my guess. I would go with 5 and 3, okay? Height of 3 and length of 5. But let's see what happens. So let's try the 1. You think 1's going to work? No. Okay, not a chance. Okay? All right. So I need to erase some stuff. So I think what I'll do is I'll erase all but my equation here. Well, I don't need that up there anyway. I need that. Okay. Really don't need that. But let's erase this. Hopefully you'll remember what the others are if we need it. Okay. I probably shouldn't erase my figure, but I just did. Okay. So, 1 doesn't work. What are your coefficients? We're going to next try 3. What's your coefficients? 1. 0. -2. -75. Remember, you got to count for every term. Got to have, if that's a cubic, you got to have 4 numbers here. Okay, then what do we do? Skip a line, draw a line. Bring down the 1. 3. 3. 9. 7. Nowhere close, right? What's that? 21. And that comes out -54. Okay. Now, 2 things I tell you. Normally, I would have just stopped there and said it's not going to give you a 0. But I wanted to show you it does get a negative number, so we don't stop. We haven't reached the upper bound yet. So we're going to try again, okay? Because that turned out negative. If that had been positive, we would have been up that creek, but not, well, never mind. Okay. So let's erase the 3 and this line and the rest of those. That 1's still going to be the 1. So what do we try next? 5. 5. Y'all are stuck on it. 25. 23. Wait, what's wrong with this picture, folks? Huh? Okay. Did I must have written something down wrong. Oh, my goodness. That's, yeah. If you go back to this, yeah, the volume of a cube is 1/3 the base, which is L squared, times the height, which is L minus 1. That's L squared. The 2 is an L, you know, if you go way back to there, that would be 1/3 L cubed minus, it only is 2, sorry, minus 2/3 L squared. I wrote L down. It's L squared. I got these in the wrong order. Okay, sorry about this. I thought I did something dumb here. The minus 2 goes there. It's L squared term. Minus 2, 0 for the linear term. Okay, so let's go back and start over again. Yeah? Yeah, 5 is okay. But we should have started at 3, okay? Oh. Wait a minute. Yeah. I erased the wrong one. Erase that one. Now let's go. 1 times 5 is 5. 3. 15. 15. Now we get 75. Ding, 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 ding. And what we know is don't go any higher. Okay. So 5, sure enough, is our 0. That was the x squared there. I'll watch that badly. Okay. So that was the length, right? The length was 5. What's the height? 3. Okay. So your length is 5. The height is 3. And these are inches, by the way. Okay, because we had 25 cubic inches. A good way to check is the length squared is 25, and 25 times 3 would be 75, and a third of that would be 25, and sure enough, that's how many cubic inches you got. Sorry, I blew that. Okay. Let's see how they did it. A lot nicer than I did. So let's erase. I don't think I need to erase it, but I'm going to. All right, the solution, they told you the volume of a pyramid is 1/3 the base, that's the area of the base, times the height. Well, the base they told you was square, so that's going to be, they said x squared. We called it L squared. It doesn't matter what you call it, okay? And then the height is 2 less than the base, so it's L or h minus 2, x minus 2, okay? So then you plug those in, and you get volume is 1/3 the base, x squared, times the height, x minus 2. You multiply that correctly, okay? Why in the world don't they multiply? I don't know. 25 is equal to 1/3 x squared times x minus 2. When you multiply that through at 75, wow, they skipped a lot of steps here. They first multiplied by 3, made it 75, then that x squared times x is x cubed, x squared times minus 2 is minus 2x. Then they wrote that in descending order of the power. 0 is equal to x cubed minus 2x squared minus 75. That's where I had the x in there rather than x squared. Dumb mistake. The possible rational solutions are plus or minus 1, plus or minus 3, plus or minus 5. We skipped the plus or minus 15, didn't we? Ugh. Plus or minus 25 and plus or minus 75. Okay? Use synthetic division to test some of the possible sources. Guess what? We're not interested in any negative links at all, so that's why I ignored those. And then started off with the 1. You could plug in the 1. It didn't work. In this case, it makes sense only to test positive, okay, x values. You don't want any negative links of candles, okay? So the 1 didn't work. The 3 we tried, and it didn't work. Even if we had written it right, it wouldn't have worked. But when we went to 5, sure enough, we got a solution, and we saw that you don't go any higher. You won't get any more solutions of that. Not going to happen. So 5 is it. L equal, or x equal 5. The other two solutions are complex. They can be thrown away. We don't want any imaginary candles here. They don't give much light. Okay, so we won't have that either. Okay, and you can conclude the base of the candle mold should be 5 inches by 5 inches. The height should be 3 inches, and that will take your full 25 cubic inches of wax. So here's an additional hint to help you find real zeros of polynomial. When the terms of f of x have a common monomial factor, it should be factored out before applying any of the tests. So if you had something like this, remember, you don't even want to do that with the Descartes rule of sign, right? You can't use the rational zeros test because it has a 0 there, okay? So, but you can factor out the x first. I told you this earlier. Then you deal with x cubed minus 5x squared plus 3x plus 1. X is a factor. X equals 0 is a possible solution. In most problems, not very interested in x equals 0, okay? If you had a candle of 0 length, okay? Not much of a candle, okay? So we would, but it is a 0, okay? Get rid of it. Then do everything else with this. The Descartes rule of signs, do your rational zeros test, do everything. Synthetic division, using this, not that. Okay? So you analyze the cubic function, cubic factor, and go from there. All right. Any questions? All right. That finishes 2.5. And it almost runs us out of time, doesn't it? So we got maybe 2 minutes. So let's do the vocabulary. Top of page 162. The blank blank of blank states that if f of x is a polynomial of degree n greater than 0, then f has at least one 0 in the complex number system. Say again? Now let's go way back. Go back one page to your summary. What's number 1 on the summary? Anyone got a book? One page back. Page 161. Summary. Section 2.5. What's the first thing it states? State the fundamental theorem of algebra. That's it. The blank blank of blank. Okay. Number 2, the blank 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 states that if f of x is a polynomial of degree n greater than 0, then f of x has precisely n linear factors. Okay? But those coefficients, not coefficients, the zeros there could be complex numbers. That's the second part of 1 on the previous page. What's that? It says state the fundamental theorem of algebra. We use that for the first question. And before that. Linear factorization theorem in number 1. Okay? That's what that means. Because look at that. Linear factors. Linear factorization theorem. Number 3. The test that gives a list of possible rational zeros of the polynomial function is the blank blank test. Rational zeros test. Very good. Number 3. They are very creative with their names here. Number 4, I'm sorry. If a plus bi, where b is not equal to 0, is a complex zero of a polynomial with real coefficients, so is it blank blank, which is a minus bi. Yes, complex conjugate. Exactly. Okay? Number 5. Every polynomial of degree n greater than 0 with real coefficients can be written as a product of blank and blank factors with real coefficients where the blank factors have real zeros. Okay? This is not in your summarization. Since we're running out of time, I'll tell it to you. A product of linear and quadratic factors. Where the linear factors have real zeros, the quadratic factors may, if they're not factorable in the real number system, they have complex zeros. Number 6, a quadratic factor that cannot be factored further as a product of linear factors containing real numbers is blank over the blanks. Irreducible over the reals. Okay? Sorry, I'm doing all the answering here. Number 7. The theorem that can be used to determine the possible number of positive and negative real zeros of a function is the blank blank of blank. Descartes' rule of signs. Very good. Okay? A real number C is a blank bound for the real zeros of F when no real zeros are less than C, and is a blank bound when no real zeros are greater than C. Yeah, upper and lower. Okay. Homework exercises here. Any of the odds 9 through 13. Do either 15 or 17 or both. Any of the odds 19 through 27. Either 29 or 31 or both. Either 33 or 35 or both. Either 37 or 39 or both. Any of the odds 41 to 45. Either 47 or 49 or both. 51 or 53 or both. Any of the odds 55 to 59. 61 through 71, 73 through 77, 79 through 85, either 87 or 89, either 91 or 93, 95 or 97, 99 or 101. They don't have many in this section, do they? And then try to do either 103 or 105, or both if you choose. Look at the true-false 107. Think about the 109 through 113 or 115. The 117 is dealing with complex things, so I wouldn't worry about that too much. And error analysis, if you want to think about that, you can. 121 and 123 are things. So next time we'll start with 2.6. Yeah, good deal. Were you able to see the score? Did you look for the score? Huh? Yeah, I know, but were you able to find the score? Okay, yeah. I want to make sure they did show up. I'll put them in there. Okay, quiz 2, right?
Have a good one.
All right, thank you. See you. Have a good weekend, everybody. There you go. You want to see it?
Yes, Mom.
Okay. Good night.
you said we don't have to worry about the application for the test. No.
Watch my mouth. No, applications, yes, but the things, the ones I said you don't have to worry about are things like think about it and error analysis, some of those at the end. But the ones over here are all fair game.
Yes.
Okay.
The quiz already standing, I haven't sent mine, so I can.
I'm sorry?
Do it for the release.
Yeah.
I haven't sent mine yet.
Oh,
so
yeah, okay.
Next week.
Yeah, that'll be fine. You got time.
Thank you.
Thank you. All right, good deal.
Can I ask you a question?
No, yeah, of course you can.
I was
a little confused about where to go for a few of these.
Okay.
I'm not sure. I don't even know if I finished number 5, and I wasn't sure. Were you asking for like
Okay.
a written?
Yeah. Yeah. Write the standard form for equation, and that means it really should be a function of the parabola that has the vertex here and passes through the point here. That would be similar to, let me put my paper in place so I don't forget where I am. Okay, this was probably somewhere back around here. Okay. Now that should be earlier. 2.1. Okay. Something like this. You see these here? It says write the quadratic equation given the vertex and given a point.
Okay.
That's what is that for? There's a vertex, there's a point. Just like these right here.
Okay, so.
And 37 is given, all the odds are given at caltrack.com, and the 37 is given on calcview.com. Yeah.
Okay.
So yeah,
You
it
can't
looks
tell.
like,
Does this look right?
okay, let's see. That looks exactly right. All you have to do is find out what your A is. So
Okay.
when you put in -7 there, and put in an 8 for the X, yeah, you'll find out what your coefficient is.
Okay, so then I need to,
You
to
continue with that
Okay.
and figure out what A is. Yeah,
Okay.
very good.
And then I think I'm fine for number 7.
But when you finish it, you go back and write it just like you wrote here, except you put in the value for A, right there. When you
Okay.
find this for A, plug it in right there.
Okay.
Yeah.
And then
Okay. Just
A?
something to point out. I don't know if you noticed, that is a minus sign. I meant to point that
I
out.
think I did. So
Okay,
number
good. Okay,
6.
that's
Yes.
Yeah, you got
I
it.
worked it
Okay.
as a negative.
Okay.
I wasn't sure where to go find this.
Okay. That
And I
would
think
be,
that may have been a day I may have been absent.
oh,
So
okay. Well, one thing I would suggest then, and this isn't vanity speaking, but if you go back and listen to that day on the YouTube video, I think you'll find, let's see, is that in behavior? I think it is. Yeah, here it is.
okay, that's beginning of 2.2.
Trying to, yeah.
2.2 example 1.
No, I think it's example 2 is probably the better one. Describe the left and right hand behavior. That's called the end behavior. Isn't that what it says? Yeah, but describe the right hand and left hand behavior. It's example 2 here. And
I was writing something. Okay, so the leading coefficient is even, and then
yeah,
okay, then I
and all
start.
that stuff is right here in this thing, leading coefficient test. I like to call it
Because I
leading
was
term
also
test.
trying to watch it on Larson, and
Right. Yeah.
there their example was really brief,
Yeah,
if I can say it that way.
right,
So I was trying to catch it and make sense of it.
right,
So I ended up having to
okay.
so
Yeah. And I don't, when I did it in class, I showed you the thing. And the previous editions did it more like that. They say, and they do it just like this, as X, and I told you before, every one of these, when you're doing right and left hand behavior, this is what you're going to infinities. And so every one of these blanks is going to have an infinity in it. One of the X's minus and one plus. I don't care which one you do which. Then you have to figure out what's the sign of the Q's.
Okay.
Because all of them are going to be infinities. You have to figure out one of these X's is plus, one minus, you choose which one, and then do the Q to match that, to whatever it is. And these rules right here tell you.
Okay. All right.
Yeah.
And I think after each, oddly enough, I can go back on this one.
Okay.
I started it, but I can go back.
Yeah.
I think I know what I have to do.
Yeah. Well, I'll give you a hint on that one too if you want. That's the factor theorem, isn't it?
Or it's used synthetic division
Yeah.
to evaluate.
Remainder theorem, I think that's it. Yeah. Yeah. To evaluate that.
Okay.
Yeah. It's the remainder theorem. And it's right there on page 140.
Okay.
Okay?
I'm getting it.
All right. Good deal. It looks like you're doing quite well at it too.
All right. Thank you.
Glad to. This is an awful lot of books. This class, back-to-back classes, two of the classes have really big books.
You done rowing class.
Yeah, but I got to go upstairs too, so that's kind of a pain in the neck as well. Oh, I didn't ever end this, so we just